And welcome back to a long overdue continuing episode of the Cloud Talk Show. Here we go.
Cloud Talk.
Yes,
Cloud
Cloud Talk. Larry, how are you?
I'm great. Living the big NYC life.
Oh my gosh. That's right. You're there now.
Quickly moved in. Yes, I moved. I'm happy.
So both of us we're both hoping for our teams to come back. I think yours already did last night, so how about it?
Yes, yeah.
I'm just putting a timestamp on this crazy Cloud Talk show here on what's going on. But yeah, whoever can do some old internet archaeology, you'll be able to figure that out in moments. In the meantime, going on that basis over here, we tried to do this show maybe several times. False starts as we were getting along, but we got so busy and everything else. So sorry for those who missed us for a while. But we promise we're going to try to get back on the schedule and going to try to get maybe some other people into this mix over here, mix things up over here, as they say. So just letting you know. In the meantime, you're probably looking at my screen right now, and you can see that I have my very quiet Azure instance going on because I'm still Mr. Cloud, and so are you. Are you playing with your AWS or any of the other services at all lately, or been quiet for you too?
My AWS has been very quiet. I did finish Pivotal training, and the Pivotal Cloud Foundry is interesting. It's coming from a Java background, and I'm a big C# head, so
right.
There's some impedance mismatch there with the training, but they're coming with a lot of good C# stuff, and we'll see.
We'll see what happens. So we're going to cover that when we get more C#. Then I'll come talk to you more about it probably.
Absolutely.
But, definitely, I wanted to follow up on that one as well because that's one of the main missing pieces. But speaking of missing pieces, we're going back to maybe we always touched on in a slight way the concept of databases, storage, things like that.
Right, and thinking of back, we're both in the upper edge of the new guys on the block, right? We've been around the block at least once or twice.
Mm-hmm.
We know where all the bumps are, and back in the day, the thing was you didn't want to be, someone put the DBA hat on you.
Oh,
right?
Oh man, that was like getting the red stapler assigned to you, basically.
Yes, because developers, I want to be developing code. I don't want to be mucking around in the data and stuff like that. Yes. So, but I mean, data is everywhere. Data is everywhere now, and
this is true. If you think about it, everything we do, the data is involved. The problem is, though, it's so ubiquitous. It's basically like. I don't know. It's like water. The fact that you have to go to the bathroom. It's like it's there. It's ubiquitous. You may not want to think about it, but it's there. You're working with it at all times. The question is, are you the person that's solely devoted to working on that, or doing more exciting things like designing the pretty golden toilet seat versus just making sure that those pipes are clean.
Yeah. Well, and now you're using ORMs. Right, entity framework and
correct,
and all that. So do we care about the database anymore? As developers, should we care? Should we,
It's a good question. We're talking REST to places, right? We got APIs. We don't give a fuck about what they do in the back. Just give me an endpoint and I'm done. Right.
Yeah.
Well. Sort of as going around the block, we end up finding out that we are drawn, as they say, we want to get out, but they pull us back in. At some point, you need to understand how some of these pieces work. If you want to be that ultimate architect or that person that really can design the bigger system, understanding how all the pieces work and having an appreciation for them, and I really mean an appreciation, not a hatred, because believe me, I've run into developers that actually hate some of this stuff so bad that they won't touch it for anything, and not realizing that you will get totally stuck because if you catch a problem, we're like, well, I see where the problem is. The data type's wrong, and you're trying to explain it to someone that's telling you, no, you're wrong. You're not using it right. You cannot communicate with them or cannot relate with them unless you understand at least where they're coming from. Right.
Right. Well, and to get back to our car talk stuff.
Yeah.
you can go down to the dealership and you can buy a Corvette. It doesn't make you a race car driver. You know, you can build a data structure in an ORM. It doesn't make you a DBA. There are times when the performance that you actually need to get out of your code requires you to dig in a little bit deeper, and as you say, get a real understanding of not just, you know, your data, but the way the system is handling your data.
Precisely.
So how does this relate to the cloud, though? Okay, come on.
Yes. Well, so basically, here's the thing. It's like, well, okay. So now we're on the cloud. So now it's worse. Now you're even further abstracted away from where it used to be. You used to have your little database, your little MDF or whatever, local to your machine. You talk to it, you're fine. But then you hear people talk about NoSQL or MySQL or MySQL, NoSQL, this SQL, someone forgot SQL, someone's doing MongoBeans, or is that MongoDB? What is it? All these different things. And you're like, it's now it was bad enough that I didn't want to be the DBA. Now I have to know all this other stuff too? Oh my God. What's the difference? Is wait a minute, I just figured out how to do a select star from blank and inner join, whatever, and now you're giving me something that's totally out of it. All right? So it sounds like it gets more confusing when you get to the cloud. But in truth, actually, it's making it actually simpler. Because here's the bottom line. That's why I have the Azure portal here as an example. The concept is if I want to do anything like this with this kind of power, just from the portal alone, I can spin any of these kind of things up and try it for myself. I can learn about it. I can at least appreciate a sample or a run through it, and I can actually use it. Now imagine, as an old DB, you would have to buy or download or sneakily install software from all the different database vendors and service vendors and everything else onto your systems. But now I just go to a service. This could have been AWS, by the way, or Google. All of these guys have similar stuff. And you can just now go in and spin these up. Poof. And you have infrastructure as if you were the data center of Reuters or somebody, right?
Right. And yeah, no, you don't have to pull that machine off the shelf.
Correct.
Or, you know, go buy a new machine or any of that. It's all just there for you.
Indeed.
And you can scale it. You know, you can start out with your toy, and then you can scale it up to be, as you say, an enterprise or Reuters or something like that.
Exactly.
So is there the equivalent of Access? I mean, you know, that was the old thing, right? We used to use Access on our machines, or
right. I think Access is actually still out there. I'm just wondering when it's gonna finally go away, but it's probably still out there. It is probably still an Office 365 product. I know they stopped it as far as quote unquote access services for SharePoint stuff, but it's still out there. It's still being used. You know, so but you're right. Is there, for example, a cloud version of like an Access where you can just go ahead and just put stuff in a table? Well, guess what? I know that they have that in Azure. There's like little table stuff that you can do over here too.
Oh, cool.
Mini tables. Like, so if we went over here, I mean, it's something as simple as this. So if I wanted to like go to databases over here, and I can see over here, look, I can get a quickie SQL database, right? I can get an Azure database for the different kinds and stuff. So I can start up and make my own data service in no times flat. Okay,
so we can build tables like Access in the cloud?
Yes, so we were talking about that just a moment ago. So I quickly over here brought up, for example, the fact that I can just go into the Azure marketplace and go look for anything I want, a good old database, a warehouse, or anything else. I could probably open up Access itself, but more importantly, I have many choices for stuff. But that, of course, now confuses people. It's like, well, where do we go? Is it storage you're looking for? Because here, look at this, storage account. Blob file, table, queue.
Ooh.
Simple. This is not even SQL. This is nothing. This is something very quick. So just to give you an idea, look, there's a little tutorial. Azure Storage. You can do a quick start on how to do it. And a quick start over here is how to do, like in the case of a table.
Tables.
Right?
Yeah.
So here's the concept.
That's what Access is all about, just tables, right?
So here's the concept. So this is a very simple concept. So I just want a table. Why do I want a table? Because I have a list of things. I have a list of things my program needs to touch. All right? I could spin up an entire SQL Server database to create my table, to use it, or I can make a file, a little comma delimited file, an XML file, all this stuff. I can do any of those stuff, or I can put it on the cloud. And here, this is all it is, as simple as this. So we have your storage account, right?
Right.
Your table, whatever the heck, and whatever the little entity is, the little things that you get out of it from. All right, and this is basically the concept. The concept is you now have an endpoint you can talk to, and you can now put it all in there, right? So that is at the very base level, right, where you are now in the cloud. Essentially, as a developer, if you need to do something quickly, and if you need a place to keep something, right, and that's the key. Are you keeping the data, or is the data essentially something that's flying around with you? Maybe what would be a good example of flying around data? A checkout, a cart, like a shopping cart, versus an actual order. A shopping cart, I'm throwing stuff in there, whatever, anything.
I'll tell you the one that blows me away, and I love it. I'm reading a book online, and I open it up in my device, and it's at the same place.
There you go.
It just...
It goes along with you. Now, is there a database entry somewhere that says, hey, you happen to be on page X and Y, but then wait a minute, you were here on this device, and then 2 seconds later in that device, how does it know that when you opened it up on that next device, you were on that page? It's floating somewhere. It's actually that little thing floating around. It's not really stuck in a table in a place where it has to go and access it and read-write operations and take a long time. It's floating around data. It's going around. Right. Your shopping cart, actually, like on Amazon, potentially can follow you from browser session to other session. It can hang out
from one computer to another. It's got a life. It lives. It lives. And it's like what we saw earlier. We saw your office graph.
Yes.
Right.
Yeah. Remember that office graph?
Oh, it's not in a table. It's just hanging out.
That's right. Now, okay, so this becomes a very, very important concept, right? So the concept of it's not on the table, so that's one case of the concept of the table, or the concept of a piece of blob content or whatever. There's that thing that people try to ask about, and we're trying to explain the difference. And this is why when sometimes some folks ask us, hey, shouldn't I be using that new Cosmos DB instead of SQL Server? And we're like, that is really not the question you should be asking. So like if I go over here and this is why they think that, I click on databases. So if I look at this, you would think that SQL database is the same thing as a Cosmos DB. So, or database as a service for MongoDB. So wait a minute. Here's a clue. Look at these pictures. They're the same. What's going on there? Okay. So that boils down to the very first thing that you should probably learn as a developer, and we're going to pass this on, very useful information for you now too, is you need to understand what the heck these kind of databases are. And I found a very cool article over here. And this is not too old. It's very recent, in fact. And it's basically how to explain graph databases to developer. The concept is, now the difference is before you figure out what you need to use, you got to figure out not so much the use case. You got to understand what they are. A graph database versus a relational database. So SQL, right, where you have a table. So I have like an orders table, and I have an order details table. That is like a relational situation. That is an orders table. A graph is something else. A graph essentially is just simply a database model. It's just a model, right, of a set of tables and columns and everything else that's got data that's basically they're not necessarily strongly integrated. And an example of that, again, remember my Office graph you were just talking about? What do I have in my Office graph? I have my Outlook mail. I had my OneDrive information. Maybe I had some account information. I had all kinds of stuff. Amazon's another good one. I go over there. I log into Amazon. I got my favorite products. I got my wish list. I got a whole bunch of stuff. Essentially like a hub and spoke. So in the center, in the middle of all your data stuff, in the middle would be me and my profile and everything else, and all that other information, the stuff about me or related to me. That's the graph. That's why it was called Office Graph.
Disparate information coming from distinct sources, but not really accessible to each other even.
Exactly. Right? So under the covers, essentially, that's what these graph databases are. It's essentially to connect those pieces and find a way to bring those together on some fashion. And basically, that's that connection. It might be complicated, it might be simple, and everything else essentially. But basically, what it means is like now you can deal with all of these kind of databases, and that's where when Microsoft did something like a Cosmos DB. And here's the concept of the Cosmos DB. The Cosmos DB was the idea was like we're going to take a NoSQL database like Mongo or something like that. All right, and essentially allow it to be distributed globally. All right, so essentially in this particular case, you see that multi-model, multi-API right here in the middle.
Oh yeah.
And you were talking about that. It was basically said, okay, it doesn't matter what the API is, all right, for talking to them. You can talk SQL to it. You can talk MongoDB. You can talk Azure table storage. It will work with that because at the end of the day, at the data at the end will exist the way it needs to exist.
Right.
All right.
And the way that you pull it out, all you're doing is you're pulling it out through a view.
Yes, exactly.
Okay, kind of. Yeah. So that API just gives us access to the underlying data.
Yes. And however that underlying data is, that underlying data can be in any format. All right, and or multiple formats, or maybe it's nice enough to be in the same format. That's all fine and well, but that's the concept. First, you have to understand where those pieces lie. All right, so I don't know. You have anything more we can talk about these crazy differences of the databases? Like I said, I got this link over here, which we'll share for you all later on.
No, I think that's great. And so what? I mean, do we still need DBAs? Are DBAs involved, or what?
So? Here's the thing, and that's the next part, really. Actually, this is what our original topic was starting today. We were asking the question, is like, do we care about DBAs and everything else? And before we started figuring out what kind of database or storage ideas are out there on the web, on the cloud or the web in the first place, we were first thinking about the roles. Like, well, what happens to us? We have to know this stuff. Well, if you tried mistakenly to put it into search and say, give me database roles in the cloud and everything else, nobody really has looked at it in one place, because there's, as you can see, most times they're going through job roles in the cloud and everything else. They're very specific about how do they deal with current jobs. Oh, I'm a DBA right now. What's my job now that the cloud is out there? Everyone's concerned about trying to tell the poor folks who are in particular jobs what they're going to do now in the cloud, as opposed to like, well, hold on a second. Here's the cloud. Here's what you need to handle data in the cloud. So that's what we're going to do today. That's our service for today. Hope it might be a unique thing. Maybe somebody's done it. We don't know. But that's our unique thing. What are the roles now in the cloud? If you're a developer, especially if you're a cloud architect, I should say, right, what you should know. And I think really you're not going to be playing all these hats. I think I discussed that at one time. It's like a person could be a jack, could understand all these pieces, but they're never necessarily going to be able to do it all. And of course, whatever they're trying to work in may not come out that good because they're only like a partial expert in all these pieces. All right. So,
well, but they don't have to be an expert because they can know enough to talk to the experts.
Yes.
Once they get big enough, once you're, I mean, okay, in our day job, we work enterprise software, so we're working with the big guys. So, but a lot of developers, and hey, the bread and butter of the development community is out there working in smaller places where, it really just that last little erg of power isn't necessary.
Right. That's true. So let's say you're the guy, you're the one in charge of this stuff. At the very least, if you're going to try to do it all, you need to have an appreciation for what the actual roles are that are out there. And if not, at least when you get into it and get learning, you're going to want to at the very least know how to find those people that have those specific skills. And we're going to have a guy in the near future that's going to probably talk about this again a little bit. We're going to like let's just say regurgitate the stuff with him again. A good old friend of ours for the cloud. We'll save that as a surprise until later. But for now, I did have a discussion with him, and one of the things that we talked about was essentially about these roles. What makes sense now to have these roles? And he came up with with five different roles. And the first one that we probably heard about is your traditional administrator, basically. But you have different kinds of administrators now. You have essentially cloud infrastructure, right?
Yes.
So you have your basically that's the cloud infrastructure role. Essentially, it's essentially the person over here is in charge of how the data will get around. That's his main thing. It's going to be getting around on essentially say through AWS. How does it happen on Azure? How does it happen? All right. Are there going to be virtual machines that are going to make it happen? Is there going to be specific technologies going to make it happen?
Right.
So that's
setting
sort
up
of
the big
like
structure.
yes.
Right.
Exactly.
The system structure.
Exactly. So one of the other ones over here, one of the other ones over here. Hold on a moment. Let's get to another one over here. And another one, of course, is when we start talking about the data itself, is the data scientist. All right. So there's a data scientist. That's a particular kind of guy. So data scientist over here, that's the person that will take the data, of course, whatever that happens to be out there, and essentially will tell you what is it about that data. Like to look at it closely, and tell you what you can do with this data.
Right.
All right. So now I want to take that data and I want to like make money out of it or something, or I want you tell me something about my data that I don't already know.
And,
all right.
and they've got some domain knowledge, but it's also, I mean, it's not just the domain knowledge. They're not necessarily. They have to have some domain-specific knowledge, but mainly it's about knowing the way that data is structured and being able to pull that data and gain information from it.
And the cloud, essentially, the power of the cloud is the fact that they're more likely going to utilize the graph, as they say, to bring those pieces together, as opposed to, like, they're not going to design it. They're not necessarily going to do any of those kind of things. They're not going to create reports for you necessarily. They're the ones that basically will try to put those pieces together. All right, so let's see. We got the infrastructure guy. We got the data scientist. What's another cloudy type guy? We have the guy that actually designs, the actual guy who designs the tables and everything else. And we have essentially, he's the true architect, right? He's the data architect.
The data architect.
The actual data architect. So this is a different guy. The data architect designing essentially the relationships and everything else of the actual tables. Architect.
There you go.
Hold on a second. Architect. Let's spell him right.
There you go.
Architect. There he is. All right, so there's our data architect, right? So essentially, that's the guy. It's an information technology discipline. He's even though he goes with the data architecture and everything else, he basically will understand how the data is stored, consumed, integrated, and all the different entities. So he's like the higher level, all right? So, it's not the table guy. I think this guy is the guy one level above.
One level above the table guy. So
yes.
Then we still have the table guy. We've got the
table guy is the actual data developer.
Okay.
I believe he's a data developer. Let's find out.
Yeah.
So that's the guy that the data developer now is that the guy below him. That's the guy who's actually now going to be creating the tables, the relationships, or anything like that. Essentially, the structure, the actual structure, based on the plans that were created by the architect.
So the data architect is sort of implementation independent,
yes.
And the data developer is the one that's actually like dug into Oracle
exactly.
and knows PL SQL and can just
or
hammer
in
it
that
out.
Azure table, actually setting up the table, the table actual names and everything else, giving those names and everything else, the bits that need to work with it.
Right. They care about the size of the record. They care about the different field formats and all of that. Okay.
Right.
I can get behind that.
All right. So I have a developer, I have a architect, I have a scientist, and I do have essentially the infrastructure guy. There's one more person missing from this, and I believe that is
storage engineer.
It's a storage engineer. Yes. Thank you very much.
I love that.
He's a different guy. Storage engineer. In fact, look at that. See, it does come up.
Yeah.
Storage engineer. Well, got to be careful. There's storage and there's storage. And we're not talking about like storage wars here. We're talking storage engineer. Let's say cloud storage engineer. How about that? There we go. That's better. All right. Otherwise, you're going to think that maybe it's the guy that's like bidding for the highest for what's behind that storage item. That's
storage wars. Yeah.
Storage wars. No. The storage engineer. Now he's a very specific guy because now. All right, he will understand essentially how to make that stuff sync, right? So you have your data, it's set up in a certain way. It's in these particular structures. Well, let's take something very simple, for example. I have data that's sitting in a SQL Server, and I'm doing searches for it, and I'm noticing that over time, all of a sudden it takes forever for that data to show up. What's going on? Hey, it can handle 1 million rows. It handled 1 million rows before. Why isn't it handling it now? It's like, well, did you re-index your data? Remember those concepts? Indexing your data and doing all that stuff. So These are the things that they would potentially concern themselves with actually one higher level than that. The
Right.
storage itself, the actual hardware, or rather the configuration of the systems online on the web, on the cloud, I
Yes.
should say, to make it happen.
Yeah, and I mean, old school, you would have people, working with the drives and striping the data across disks and
Right.
setting up your LUNs. Ooh,
Oh, boy.
anybody remember LUNs?
Oh man. Well, now someone else is actually doing that in person somewhere else for you.
Right.
But now you
Right.
still have that engineer to understand essentially the storage bits that have to go and try to, as you say, to optimize it. They're doing it
Right.
with configuration parameters now instead of actually going in and touching hardware.
Right, but you've also got geolocation and geo-relocation.
There we go.
Replication rather. Excuse me.
Yes.
And all of that you have access to in the cloud with the click. Well, okay, it's not just the click of a button, it's the click of a button and the swipe of a credit card, but
Correct.
it's still there.
Exactly. So
Cool.
you have all those pieces now. Mind you, these are just the database type roles that we're talking about, or the database related roles. Obviously, there's other roles that are going to be out there. The security guy, there's data involved there. Sure. The reporting guy, yeah, sure. There's data involved over there. Or the gal that's doing the presentation screens for the forums and everything else. That really is part of the presentation layer, the higher piece. Well, not security, of course. Security is its own thing, which we'll cover another time. But on the presentation side, this is not what this is about. All the stuff we're talking about literally is sitting in that edge where, like, I'm the developer. I'm talking to now. I'm getting my data from somewhere, and that somewhere is that person. Either I am him, because I don't have him right now, so I got to do something in the meantime.
Right. Or you've got to call her and you've got to say, look, I've got this data and I need it stored, and
Yes.
and she's like, oh well, you should look at Azure storage as opposed to Amazon because
Right.
the structure of your data is such that their underlying infrastructure is better suited to the types of requests that you're going to be making, and you don't have to know necessarily what she's talking about, but you got to be able to explain the concept in a way
Right.
that can be understood, using the appropriate language.
Well, that's true.
Whatever.
You don't want to be bamboozled anyway. If they come back and tell you
Right.
you need AWS over to Azure, and I will tell you right now, it's going to be like, the only reason we're probably using AWS over Azure is because there's a money thing going on.
Right.
Because if you're going to tell me that there's something in the technology, specifically on the data storage piece or one thing else that one has and one doesn't have, then I'm going to say you're trying to just to fool me, right? Because at least now I understand, now that I've used it or I get to play with it, I can understand that you're trying to tell me something, you're trying to sell me something now. You're not really solving a problem. However, there are some true issues out there. The concept of like, well, some things are meant to work in a certain way because that's the way the architecture of that thing is built. Service Fabric, I heard, was an example of that, where in the case of like, if you had like transactional data that had to like be really that had to stay put, it wouldn't really work in that particular mode because of the way Service Fabric was built, right? Because the transaction essentially could be duplicated because it has no idea what anything else is going on. It's trying to do everything at once. It's completely async. And there's no concept of how do you take something async and make it synchronized, and then at the same time scale it out. All right. The whole point is I want to be scalar. I want to scale forever. Well, which means that you give me something, I'm going to do it. If you gave it to me again, well, I don't know because you gave it to that guy over there who's taking care of it, and I don't know what you gave him. So I'm going to take that and do it again, and then pass it on again because there's nothing to tell me I can't do it. That was the problem with Service Fabric in a nutshell. A little issue. But then, of course, the people who designed their system probably should not have taught to use Service Fabric. They probably said, hey, this is scalar. This is so powerful. I can do millions of transactions. They say, well, what happens when you do a duplicate? Oops.
Oops.
Oops. And it was like a simple thing. Okay, that means you can't handle duplicates. This means if you tell me off the bat, there will never, ever be a duplicate. Everything that you put in through is good. You're good. All right? So here's an example of like understanding now the data as a developer. And as an architect, I can now say, okay, I can't use that service or that system because that service is Scalar does not give a hoot about any of the transactions. It's great if I'm doing stuff that it doesn't care about, all right? But if I want a transaction system, I can't do that. I got to use something else, something that truly is, just like good old, maybe I needed a true transactional system that says this transaction is not complete until it's absolutely complete. Every step of the way. If it breaks, if the system breaks down, if the message was lost or dropped, the system essentially either kills, never ever finishes, never completes, all right? Or the system will never let me do duplicate because when it goes out there, it's always checking somewhere and says,
so now it's time. Now it's time to roll up the sleeves and get old school.
Yes.
It's like TCP and UDP.
Ooh.
Okay. It's like fire and forget. UDP, man, you can scream because you just keep shooting, and if the request doesn't come through in the right order, we don't care. We're going to reorder them. If you miss one, it's okay. We'll ask again. Versus TCP, when it's steady, they come in the right order. It's a little slower, but you've got reliability. So, I mean, you could build on top of it this whole structure, but why not just use the right thing?
Exactly. Right. So, and again, look at how you're coming in. You're coming at it again from the other side of the piece, right? You're talking about from the network side.
From the network side, yeah.
From the network side, exactly. But that again has that relationship. That's why we talked about earlier about the cloud infrastructure guy as being a guy, right? Because he's essentially data on the network.
Right.
Right.
Now, and okay, I sent you a link. I've got to come down. Yeah, I did. I want to talk about cheap. We've talked about I squeak when I walk.
All right.
Man, I'm telling you, this is the way you get.
Here we go.
Yeah, backplace.
We saw this before.
Cheap storage. Yes, cheap storage. But it's in a different data warehouse than my compute. And so I have to pay to get it moved around, and I mean, but there are certain situations where this is exactly what you need. This is cheap. This is just what you need. But it's not every situation, and you don't necessarily know as a developer. You don't have to know. That's why you get these data scientists, these people that understand, are the storage engineer, for example, and she says, look, your data is there. You're not touching it often. You're only accessing it in this pattern. So, man, that would be a great choice for you. Or no, you're rolling through all of that data every day. So we need to put that close. We need to put it there and have it be just part. In fact, you know what? We're not even going to put it on a separate server. We're just going to get a disk, and we're going to attach it, disk attached to the virtual machines themselves. It'll just be a shared read-only disk. I mean, there's crazy stuff that people like that know how to do because they've done that pattern before. Best way to learn it is to do it. That's the way you learn.
At the end of the day, and again, the reason why you want to learn it, if you're not going to necessarily do it, you want to maintain that understanding. You got to realize at some point somebody will have the red stapler, and remember, the guy with the red stapler got the money in the end. He got it all. He did get it all.
Absolutely.
He did get it all. So, and at the end of the day, didn't matter how nerdy and how cool we were. He got the money in the end. So
that's right.
Let's just remember that. The garbage guy probably makes way more money than I do right now because he's doing something that nobody else will do, and that's why they call him an engineer. And me, I'm just a developer. Oh well.
All right. Well, we'll try to do this again more often.
Yes. And we might have a guest in the next
show.
We'll
topics.
See. We'll see what happens, and maybe talk more about data. Data is still very cool, so maybe the rest of the year more data. Unless you got a different topic, we're going to continue on this path.
Sounds good.
All right, Mr. Laird, that's the end of our show, and we'll catch you on the next one.
All
All right, take care.
Bye-bye.
Bye-bye.